the end of it that says force. So the command here, MPLS LDP router ID interface, then force. If you change the router ID after the LDP session is already up, it's not going to come into effect until you drop the connection. You essentially bounce the interface. Somehow break that neighbor relationship there. If you force, it'll interrupt it, and then it'll essentially reset it. So that's the basic idea behind it. So if you need to switch the LDP router ID on the fly, the way to do is use the force option there. Okay, this is very important. Okay, this part about ensuring reachability to these router IDs is very important. It is like the #1 goal that you're going to have is to make sure you have reachability to everybody's router ID. So everybody's loopback, I should say. So everybody's loopback here. Make sure you have reachability to everybody's loopback, because that's how you need to build these label switch paths. Because this can be based off of the loopbacks here. For ATM, if you cannot form an adjacency, what you can do is you can do a show MPLS interfaces, the ATM interface, and then detail, and it'll show you the control VC that you're using. Make sure you're using the appropriate one. If not, you will not form an LDP neighbor or a tag switching neighbor if that's what you're doing across ATM. You can go into the global config and tell the router not to advertise labels for whatever reason. So if you don't want to be, if let's say for whatever reason or another you got a router that's having some issues and you want devices to route around it for a while for their for them building their label switch paths, you can go into global config and say no MPLS LDP advertise labels. The default obviously is to advertise out your labels there. But if you did this, this is going to disable the advertisement of your labels there. And obviously devices will start routing around you. Okay. Common issues that people run into. Protocol mismatch. So they configure MPLS IP into the interface, and then they can't form a neighbor, they don't have an LDP neighbor or tag switching neighbor, and it's because they got a protocol mismatch. The biggest problem people run into is no route to the neighbor's router ID. So you don't have a route to the neighbor's router ID. This route cannot be via BGP. See, it says IGP route. LDP uses IGP, okay, to determine how it's going to build its labels and so forth there. It doesn't use BGP. BGP has its own mechanism for labels. Okay, so for LDP, you must have an IGP route to that router ID. If it's in BGP, redistribute it in to your IGP protocol. Do not assume, like when you're going through the practice labs, do not assume we're going to tell you every time you need to redistribute this in. Okay, if we have you advertising your loopback via, if we have you advertising your loopback via BGP, you may have to go on your own, and you may have to go on your own and redistribute it in. There's a question. It says here, when do we need to use the command to change the router ID versus the transport? You can use the transport. Essentially, you're essentially saying what you're going to set up your LDP TCP connection for. This is your transport here. All right, so You can, if you do have, for whatever reason you want to set your session up based off your interface, you can do that. But normally, if you are trying to work around some issue like reachability to the loopback, you also set the router ID to the interface. So you set the LDP router ID to the interface, and then you also do the transport off that too. All right. Another possibility is LDP communication is filtered, NAT, access list, something along those lines there. Fourth possibility is mismatch in LDP authentication. So you could possibly have a mismatch in LDP authentication there. So, these are the common problems. Most of them relate to the router ID. The first thing you're going to check if you cannot form adjacency, make sure the protocols match. Make sure you have reachability to the router IDs, whatever that is. If you set the router ID to the local interface's IP address, that means the remote in has reachability through an IGP because it is directly connected. Okay, so if you have a situation, where you need to form an LDP neighbor relationship with a router in another AS, and you're not advertising that loopback through some sort of IGP because you're using BGP, the thing to do is to set it to the interface. You'll see this in the workbook there. All right, you'll see at least, I believe, at least one example for this here. Okay. Make sure someone had another question here. They said, will LDP come up if the router ID is not reachable but the transfer? Let's look at the problems here. Let's actually do this here. Let's look at the problems that this creates. So what we'll do here is we're using our same standard topology we used all week here, and we will create this exact issue. Okay. So here, and what we'll do here is let's break OSPF between R2 and 4. Well, we're going to run LDP between 2 and 4 here. Okay, this is, I was doing something earlier here. Let me take this back off. MPLS advertise labels here. Okay, now what I want to do, router OSPF1, and let's see here, and passive interface FA0/1, and let's go over to 4 real quick. Router OSPF1, passive interface E0/0. What I'm going to do is I'm going to go ahead and passive out the R2's ATM interface too, just so R2 doesn't have a route to R4's loopback any way, shape, or form. All right, here's how you use the passive interface before the passive interface command was added to the iOS. Okay, shut down. That'll passive out that interface. All right. Now let's remove it from the let's remove LDP from the interface because it was already on here. It was already enabled here, I should say. And you can get into these weird problems where it's like, well, this isn't supposed to be working, but it's working, and it's because it was working when it was configured properly. Now you change your configuration, and you just assumed all of a sudden it would break itself, but it ended up not breaking itself. So try to break it back to like a basic config here. no MPLS IP, especially if you see something working that shouldn't be working. Okay, so the neighbor went down. Okay, show IP route. We don't have any routes. Show IP route, and this is going to be R4's router ID here. All right, so let's try to bring this up here. All right, this one's probably 50-50. It's either going to work or not going to work, right? Okay. What I meant was, even though it doesn't have a route, because it was up earlier, now it's just going to decide to come back up again. Discovery, okay, it tells you right here. It says no route. So we don't have a route to that router ID. We can't establish that here. So let's go under the interface. And let's specify transport address here. And the transport address will be 150.1.24.2. And we'll go onto R4 and put the same thing here. Interface E0/0, 150.1.24.4. See if that makes it any sort of difference at all. Still trying to route to that. Even if we source the connection off of the interface, it's still trying to get to that router ID. See where it says the router ID here? But we're going to have a problem trying to get to that here. So it's not going to come up here. So let's go ahead and MPLS LDP router ID FA0/1 force, and let's go to 4 MPLS LDP router ID E0/0 force. It hasn't learned that there's a new router ID here. Okay, there it is. There it goes. Now it came up. So even though we specified what interface, that we're not going to generate our TCP session off our loopback, but yet it's going to be the interface, that didn't help because we still needed to get to that loopback there. So we still needed to get to that loopback there. Okay. So what we did is we just forced it to the interface here. And show MPLS forwarding. The problem we're going to run into, though, is we can't reach the other device's loopbacks. So, we're really not going to build, this solution really brings up the LDP neighbor relationship, but you're going to really have some trouble with trying to build, the LSPs. Because you don't have reachability, I don't have reachability to those other loopbacks there. 50.1.0.0. Let me do this. Show MPLS label bindings. For this version of iOS. For this version of iOS, I'm going to do a show MPLS IP bindings. You can also do a show MPLS label bindings. As we see here, we are learning about labels. But as you see here, no route, no route, no route. Even if I learn these routes via BGP, router BGP, Just make this guy router BGP 1, 2, neighbor 150.1.24.4. What am I doing that for? It's Friday. Remote AS 200. And let's go to 4. Do a peering session back, and we'll redistribute OSPF into BGP. Router BGP 200, neighbor 150.1.24.2, remote AS2, address family IPv4, unicast, neighbor 150.1.24.2, activate, and redistribute OSPF 1, match. You always want to get a habit of this, internal, external 1. We don't necessarily need it in our case because we don't have any externals in OSPF. Show IP route. Let's look at a route for, let's say a route for 6's loopback. See if we learn it. We do have it via BGP. So it is enabled through, sorry, not enabled, but we do have the route through BGP, but since it is not an IGP route, we do not build a label for it if we're using LDP. So just remember that LDP is an intra-domain protocol. It's an intra-domain. You've got to have some sort of IGP route, either it's connected or it's static, or it's learned through some some sort of IGP protocol, but it can't be learned via BGP. So you can see here, even though it says it doesn't have a route to it, so we've learned about this label, okay, but we can't use it. We don't have a route. We don't have an IGP route. LDP uses IGP to determine which interface it should forward out. So if it's got 2 possible destinations, let's say if I'm learning labels from about a destination from 2 different sources, if I'm learning labels from 2 different sources, how do I know which one to use? I'm gonna use whichever one the IGP route would route to. So if I'm learning it from R1 and R4, and the IGP route says go to R4, well, that's the label I'm going to use. Okay, so this is showing us it's equivalent of the show IP OSPF database. It's the exact same logic here, or the IS to IS database. So we're looking at, the database here. So this tells us that LDP is working, but yet it is failing to actually populate the LFIP. Show MPLS forwarding. Nothing's there. IP route 150.1.0.0, 255, 255.0.0, 150.1.24.4. There it goes. It'll start to build it now. If I want to get the details, I could say, just put this a little bit more specific. And 6, and let's just say 3. And you can see it's building this here. But you also see there's a problem, though. If we did that route, if we put on these static routes, you see where when we did a /16, it said pop that label. That's not what we want. We don't want to pop the label. We don't want to pop that label for all those loopbacks, essentially. Ping 50.1.6.6. That's pretty nice right there. Yeah, you get half the routes. we're not trying to enable reachability. I've got some sort of, I don't really have this network advertised out there properly to the rest of the network there, so it may be a reachability problem between 6 here. See if I get let me put a static route on for 5 so we get up to 5 real quick. You guys are probably sitting there going, oh, here we go again. Okay. Trace 150.1.5.5. And you can see here, we did use MPLS to get there. So we used MPLS to get there, but we had to do a lot to make this work. You know, this quote unquote interdomain, LDP configuration, because we had to put on the static routes. But as long as we understand this, that LDP needs an IGP route, it needs an IGP route or a static route or a directly connected route. First of all, you have to have that IGP route to the remote side's router, LDP router ID. Okay, if you don't have an IGP route to that, you're not going to be able to build the LDP neighbor relationship to even begin with. Once that occurs, once you've got that problem solved, your next step is to get the router to install those labels, that label information that you have in the lib down to the LFIB. Okay, and in order to do that, you've got to have an IGP route to those IP addresses in there, the ones advertising those labels there. If we don't have an IGP route, you're not going to build it. Just remember that. And remember, when you're doing these practice labs, it is your responsibility to do whatever you need to do to make sure you have reachability. Don't think you're going to get in here and you're going to see, in the practice lab, and it's going to say, please redistribute your loopbacks in so that you have reachability. It's not going to do that. It's going to expect that you know the protocol we're using is LDP, and you know that you need to have an IGP route to those remote loopbacks there, so that you can build that label switch path. All right, I can't emphasize that point enough, because when you're learning MPLS, it'll be one of the things that just bites you over and over and over again. Let's say you're learning, let's say you're learning the loopback through IS to IS, then all of a sudden you start peering BGP and you learn it through BGP now. It's not going to work for you. You need it. You need it through an IGP. So just remember, LDP, IGP, they go hand in hand. All right. The example we showed here was, it's not a real world type config. It's more of one of those type of CCIE things that tries to see, do you really understand what's going on? Do you understand the difference between, using like LDP or over like BGP? For traffic engineering, our other option that we have, we can't do inter-domain traffic engineering now, at least in the iOSs that we have. I mean, it is possible. There are standards being drawn up for it, but with the iOSs we have now, we can't. Because remember, that information remains within that area, like for OSPF or IS to IS. It doesn't propagate out. So this solution here, it's more of a, I'd step back. I'd say it's not a solution, it's a workaround. Okay, there's a difference between a solution and a workaround. A solution is something that, from a real world perspective, that you're going to leave on all the time, and you're not embarrassed to show somebody something you did. A workaround is like, I've got some crazy requirements, and now I'm going to, do this, to make this work. All right. Okay, here. And that example is in the lab. There is a couple of, I think there's like one scenario that draws up something like, ends up with something like this here. Okay. Just as a side note, I'm really going to not in the lab, in the workbook labs here. I think it's lab 7. where we have BGP running but not the LDP. Where we have BGP going and we were having to use LDP. So I think it's in lab 7 that we have it here. Okay. All right. So, not a common scenario, but it's something you want to be familiar with. More than likely, though, you're not going to see. There's so much to do as it is in the real lab. You're not going to see a lot of crazy odd stuff like you see in the RNS lab. And I talked to you guys earlier about this week. The CCA lab is really trying to get away from a lot of really crazy configs by just putting more devices in. And you can test someone's experience just as well by giving them a lot of things to do in a short amount of time as you can do with putting a lot of crazy, odd configs on there. All right. Let me switch back to the whiteboard here. Okay. As a side note, this question, this really didn't fit anywhere. Make sure that you use the same router ID. Any chance you are given to specify a router ID for whatever reason or source any traffic off of the router, use the loopback, the same loopback there. Okay, so use the loopback there and try to source everything off it. As Brian mentioned when you guys went over multicast and MDT, a lot of the RPF check is done against the BGP peers source, which is which is normally their loopback. Okay, so traffic engineering, you specify the router ID for your IGP, for your LDP, and so forth there. For BGP, just hard coded in there. All right, various commands here for control plane troubleshooting. A lot of these we have looked at already. Show MPLS LDP neighbor. You got to specify the neighbor IP address. Most of the times when you're working through the workbook labs, you're really not going to have such a big network. You've got to get in there and say the exact neighbor IP because I got 5 LDP neighbors off this interface. You can also look at it by interface here. Show MPLS LDP bindings. This command used to be show MPLS IP bindings, and that is in 12.2s. Yeah, so that's in 12.2s. That'll show you the labels that you're learning, and the next step is to show the labels that you're using, and that's related to the forwarding plane. Show MPLS forwarding. A few of the debug commands. Usually LDP's configuration is simple enough that you can just get on and look at the config, and then the show, well, basically the show MPLS LDP discovery command, you can use that command to pretty much determine what the other side is configured for. All right, so you can get an idea of what the, I should say, what the other side's configuration is based on the discovery of each side there. You can do these debugs if you want to know what's changing in the lib. Debug MPLS LDP bindings, debug LDP IGP. If you want to see the interaction here, you notice it doesn't say debug MPLS LDP BGP because it doesn't work for BGP. LDP doesn't. Then also one command that may be useful: debug MPLS LDP messages, message and then sent or received, just to see if you're receiving this information, and it'll also give you a little bit of debug output about that session trying to come up here. And debug MPLS LDP session, it's just your current session that's going on. usually most of the commands you're going to do are related to the show MPLS LDP discovery or show MPLS LDP neighbor. Possibly the bindings because you want to see what you've learned. Okay, so you want to say, hey, am I learning LDP labels from this remote device? Yes or no? Okay. All right, so control plane, usually not where the issues lie. I would say 90% of people's issues lie in the forwarding plane. So that's where most of their issues lie. So let's talk about it real quick. The main command we're going to look at, show MPLS forwarding. And then, normally you probably want to clean it up a little bit and then do like if I want to look for R3, I'll put the IP address, 150.1.3.3. So this is the main command that we are going to use here. Normally, the IP address we enter will be the next hop for the VP and V4 peering session. Okay, if it is a route reflector, maybe you're doing some sort of, an example would be when you get to some of the workbook labs, you'll see some inter-domain VP and V4 peering, and it peers to a route reflector. You're going to essentially look at the router that's routes that's being reflected to you. You're going to look at its IP address, because even though I'm pretty sure Brian went over this when he went over like route reflectors. Even though if I have a situation like this here, where these three routers here, two of them are in AS, just say AS2, and this guy over here is in AS1. The peering is our network setup here. The peering is set up for the top two routers where it's been highlighted green here. That's where we're peering. Then peering down to here. This top router here is a route reflector. This router here is a route reflector. When you're doing troubleshooting for MPLS, your label switch path in this design will be, your label switch path will be directly in this direction here. It will not be to the route reflector and then over. So in this case, you're going to do a show MPLS forwarding on the router in AS1. You're going to do it on its, more likely its loopback's IP address. All right. So, but normally, besides this case, it'll be the PE router's source interface for the BGP session. So that's what you're going to be looking for here. All right. Because remember too, I wanted to draw this out earlier this week. Let me jump to a whiteboard real quick. When we're doing like MPLS VPNs, so when we're doing MPLS VPNs, I want to show you guys one of the ways that I kind of look at it. Let's say I got this design here. Move this over a little bit here real quick. And let's say I have this design here, don't reveal every redundancy. Let's draw this out real quick. All right. It's way out there. So if this is our core network here, these routers here, like the P routers on our network, the only routes they're going to have, the only routes that these guys are going to have, they're not going to have the external routes. All these routes in here that are external, they're not going to know about. Okay, these routes that are in the VPNs, they're not going to know about them. Okay, and these routers here in the middle, so when you're doing your troubleshooting, just kind of remember that these routers here in the middle here, they're not going to know about these routes on the outside. So don't try to do any sort of trace routing. Don't try to do any sort of pings to devices, out there in the other VPNs here. So on the VP routers here. The P routers obviously will have routes, we'll have these routes here. But the whole idea here is all these label switch paths will be built upon getting to the remote PE's BGP source interface, that IP address. The label switch paths will be built to all these guys' loopbacks here. That's what we'll have here. Don't try to get in here on the P routers and try to do troubleshooting for reachability between the MPLS VPN. One thing you may do is make sure that the label switch path is set up correctly. So if this guy's router ID, let's just say for simplicity's sake, is 1 and 1.1.1, and this guy over here is 2.2.2.2, you're going to make sure you're going to go through the network and make sure that label switch path is set up from 2 to 1 and then 1 to 2. Okay, and then back the other way. One thing you may try to do when you're troubleshooting, you may try to ping all the way across and do a debug IP ICMP to see if it makes it all the way across but doesn't make it back. So you could have a label path built one way but not built back the other way. All right, and just remember where you're doing most of your troubleshooting is on the PE routers. Don't be alarmed when you go on to the P routers and they don't have all these routes. Okay, or the routing tables or their MPLS forwarding tables look really small. That's the whole idea of it. Okay, so these devices, these P routers now stop routing based on destination. They now switch labels. So just remember that when you're doing your troubleshooting. Don't hesitate to turn on debugs and see if the path is built one way but not back the other way. It's actually probably one of the of the top 10 problems you run into. This will probably be one of the top 10, maybe not a 6 or 7 rating, but you'll have label switch paths built one way but not built the other way. Okay. The only time that this may get a little misleading to you is when you get in a situation of the route reflectors for VP and V4. And one thing it'll throw people off too is, if this is a route reflector for, VPN, so VPN V4, but this guy is down here is the route reflector for IPv4. That kind of throws people off from just a logical standpoint. Okay, make sure that you try to draw this stuff out and think from an abstract sense. Don't think, if you see a scenario like this, and I think you're going to see it early in the workbook. You see a scenario like this, it will throw you off. Okay, if you've never done it before, because you've got IPv4 and then you got your route reflectors, then you got your VP and V4 route reflectors, and they're totally different. All right. So most of the time, it will be the BGP peer. So the peer you're peering with, if you're a P router here, a PE router, it'll be the BGP peer that you're peering with. If you don't configure BGP, you are not a PE router. You're a P router. Okay, the different options we have, we talked about this week already. Pop the tag off, untagged. Untagged's the one that's going to kind of jump out at you. Okay, because you know this has got to go across our MPLS network, but yet it's marked as untagged. Reason things could be untagged, you don't have a route to it. MPLS is not enabled properly through the network. But for some reason or other, you don't have a label switch path built here. And aggregate, we went over that this week already. That would be like on a P router when it's going to aggregate me like a route for an MPLS VPN. So it's going to remove the label and do a fib lookup on it to see where it's going to forward it. A zero label might throw you off because you may not have seen a zero label, but that's just an explicit null label. Most of the time when we do show MPLS forwarding, we see like 2316 or 2318. So you see a local label and a remote label there. So the explicit label here is just saying, we talked about explicit label. Why would use explicit label? Usually, like we said, it's to carry some QoS markings down to the remote router. Okay. Common commands here that we will deal with: show MPLS forwarding, one of the most important commands. Okay, because remember now, like when you're doing your IGP routing, one of the most important commands: show IP route. Now that we're not routing anymore based on destination IP address, we are switching labels. This is essentially the table we need to be looking at. Show MPLS forwarding here. Another thing too, make sure you look into the VRF's routing table. Make sure those routes are there. Show IP BGP VPNv4 all summary. This can actually be summarized by show IP BGP VAS. Okay, of course with a space. But you type this a lot. What you want to see is you want to see that VPNv4 peering session, and you want to see that how many routes you are receiving. Okay. Examples of times when you would not receive routes is you don't have an import target set for the routes that are being sent to you. Or the routes are not being redistributed in. We'll look at a few of those scenarios real quick here. To actually look at the routes, we're going to do a show IP BGP VPNv4 all, or V space A. Okay, so it's going to show us the BGP tables. Okay, for the different quote-unquote VRFs, which is essentially going to be, for this, is going to be route targets here. Another problem people run into, and you probably see me do it once or twice a week, is ping. They forget to put the VRF on it. Ping the VRF and then the name of the VRF and then the IP address. Very easy to do. Trace route also for the VRF. Make sure you trace route within the VRF. One of the things I recommend when you make a lot of configuration changes, you want to do a clear IP BGP star. So you want to do a clear IP BGP star. Anytime, personally, let's say if I'm doing a lab and I make a lot of changes for whatever reason or another, maybe my original solution didn't work, or I wasn't for sure of the exact solution. If I start making a lot of changes to my router's configuration, what I like to do is save my configurations, okay, then reload all the routers, and then take a quick break, come back, and then continue working. So let's say I made a whole bunch of changes, but now my configuration's up and working. Two schools of thought on this. One of them is it's a house of cards, and I really don't want to touch it. Okay. The other one is this should work. My configuration is working now. It should be able to survive a reload. So what I like to do, I probably, in the CCA lab, I probably reloaded my routers probably about 3 times. And once in the morning, once in the afternoon, and then once during the final verification. I like to reload them, especially right before lunch, because everything should still work. If it doesn't work, I'm probably not going to pass anyways. Don't hesitate, but as far as reloading the routers go, don't hesitate also to clear IP BGP, do a hard reset on the BGP peering session. I think I showed one time this week where we changed the import and export targets for a VRF, and the routes were not going across, even though we cleared it on one side. Going on this side, on each side where you change the import and export target, enabled the routes to be advertised through VP and V4. And the other time you saw us do this week, where we didn't have routes in the VRS routing table, but yet they were learned via VP and V4 BGP. The way we fixed that, clear IP route VRF, the VRF name and star. The biggest one is your configuration. You'll see that of the problems you run into, 85 to 90%, maybe I'd probably say 90 to 95% will be configuration related. Something with your configuration is missing, whatever that is. Either you forgot, one of the common issues are you forgot to do route redistribution, you didn't redistribute the routes into BGP, under the VRF, you didn't redistribute them back into the IGP, you forgot to put a default metric on. Another possible problem is you redistributed OSPF in, but you forgot to say match internal, external 1, external 2. You forgot to leak routes into IS to IS. Make sure you understand how to do route leaking. You'll see that in the workbook a lot. You forgot the issues with redistributing, IS to IS into another protocol that it doesn't bring in the connecteds and so forth there. A lot of problems with route redistribution. Okay, a lot of little problems that people run into with route redistribution there. Other problems are flat out just misconfiguration. You need to get on there, take a look at what you have configured. Sometimes it's best to pull your configs off, put them in Notepad, and look at them side by side next to the other router's configuration. Let's say if I can't build a BGP peering session for whatever reason, it's not coming up, pull it out real quick of your routers. Pull that BGP part out, put it in Notepad, and look at it. Look at line by line for each router's config, and make sure that everything syncs up. It's so easy, at least for me. It's so easy to just quickly look at it and I'll see 54.144, or I'll see 54.444, and I'm supposed to see 54.144 or something like that. It's so easy to get little things like that flipped around. All right, and as Brian showed you guys all week here, he emphasized the reload command. Kidding. But don't hesitate to reload. Sometimes it does fix it. Sometimes the reload will fix it. Sometimes you really do have to reload. There was an issue recently that there was no way. It has something to do with putting on a VRF. I was doing a VRF. I changed the route descriptor for the VRF, and it just wouldn't take, and I ended up having to reload the router to get rid of it. There was another command. Oh, I know what it was. There's a new feature that lets you import routes from a VRF through BGP into the global table. And the feature didn't work for the iOS we tested, and it just flat out totally hosed the VRF when we did that. So we were trying to import the routes from BGP's global table into the VRF table through BGP. And there's a new feature for that, and the feature we were trying out, it's not the iOS that you guys are going to deal with here, but the feature just flat out did not work. And once we did it, and you essentially had to reload your router to get rid of all the problems you had there. All right. One thing I'm going to show too. Yesterday, I had an issue with traffic engineering. You guys know we started a little late, so I was pasting my configs in there. I want to explain what my problem was. It's really beyond the scope. The type of configuration that I had on there is pretty much beyond the scope of the SP lab, but it's good to know. We do cover it a little bit, but not a lot. With traffic engineering is normally set up between PE routers. Okay, so it's normally set up between PE routers. How does a router know it is going to be a PE router? Well, you configure BGP on it, right? Multi-protocol BGP on it. A PE router. I mean, you could also do like VRF Lite, but for traffic engineering, if you have a router that is a P router only, well, so let's say if you want to do traffic engineering between two P routers. Yesterday, when I put this config on for traffic engineering, something didn't look right, and I wasn't really for sure what the problem was at the time. But when I pulled the configs out and looked, I could see that the router wasn't configured as a PE router yet. Since it wasn't a PE router, okay, since it was still a P router, since it didn't have like BGP configured on it, what happens is MPLS is not enabled under the tunnel interface. So if you're doing traffic engineering from P router to P router, you would actually go under the traffic engineering tunnel interface and say MPLS IP. So you would actually go on there and enable MPLS. And at that time, I would have started to see the labels. But since I was assuming the router was already a P router, I should have checked to see if my BGP configuration was there. Another way you could have found out this problem is do a show MPLS label binding. Or show for this iOS 2 IP binding here. The other iOSs, it was show MPLS label binding here. What we would see here, it would have said lib not enabled. So it would have said lib not enabled there. See it there? R5 is a P router. So R5 is a P router here. So R5 does not essentially have a lib enabled here, since it is a pure P router. And in this case, in this case here, if we put on multi-protocol BGP, he would start to build a lib here because he would be a PE router. So just wanted to bring that up real quick. That was the problem yesterday with my config. If I would have gone on and finished the config and put BGP on, the problem would have went away. Another problem I want to mention here, when we talked about the other protocols, we talked about ways to deal with looping. We talked about methods. Let me go to the whiteboard here real quick. We talked about methods to prevent looping when we advertise routes into a VPN. Look at this here real quick. Okay, we have this situation. This is our up top here. This is our let's just say this is VPN. VPN B here, and of course this is our design here. This is 3, this is 6, this is 7, this is 8. There is a mechanism in OSPF we didn't mention to prevent routing, to prevent route looping. Okay, so it prevents a route essentially from, the logic of this is we want to stop a route from, you know, going from a PE router down to a CE router to another CE router and then back up to another PE router and then get passed back into get passed into the, you know, the MPLS backbone here, or sorry, to another VPN site, I should say. So what we want to do is we want to have a mechanism within OSPF to stop this. Just like, remember what we did with BGP and EIGRP, we used something called site of origin. OSPF has a feature called the down bit. Okay, and what it does is when the routes come from a PE router and are sent out, they get the down bit set. If you are another PE router, you will drop those routes. The down bit is supported for type 1, 2, and 3 LSAs. So type 1, 2, and 3 LSAs, the down bit is supported for. So let's say if I have had a, you know, another site over here in, this was also in VPN B here. So this was in the same VPN here, B, and it was learning routes, or I should say advertising routes over here to 6 here. If I have a route, if I have a situation where I want to stop potential route looping here, OSPF does it automatically for us here. So if we're doing like a sham link, so we're getting the intra-area and the inter-area routes, this situation here, the route will come across, it'll go out, but it can't come back up to 3. 3 will not pick it back up. So it will not pick it up and send it. Not a problem, not a big deal at all. Okay? If your router is a PE router, it checks for this down bit. If the route is external, the down bit is not carried for external routes. So if the route is external, it can get fed back. So if you have an external route, it can go from 6 to 8 to 7 to 3, and then, you know, back, you know, to another VPN B site there. So that can possibly occur. But if it's an inter or intra-area route, it cannot. The reason I want to bring this up is, if for some reason or another I went on to, let's say, R7, and R7 I wanted to do, let's say I was connected to another router, and if I wanted to do VRF Lite, so if I wanted to do VRF Lite here, if I did VRF Lite, the router becomes a PE router. So it starts to check here. It starts to check to see if the down bit is set for any of the routes. If it sees a route with a down bit set, it'll drop it. So in this case here, if a route is, let's say the backdoor link is broken here. So this backdoor link is broken. Now the route goes from 8 to 6, 6 to 3, and 3 to 7. If 3 is doing VRF Lite, it's a PE router now, and it drops those. The workaround for this here, let me show you the workaround for this. So share out my screen real quick. Really simple to have a workaround. Well, there's actually 2 workarounds for it. One of them is to make all the routes external. Once the routes are all external, we're not going to have that a down bit set. But if we're over here on R7 here, so if we're over here on R7, what we'll do is, let's say we're doing VRF Lite and we're running OSPF with we're running OSPF with, you know, a device or whatever there. Let me do this real quick. I can bring this up, I can show you the command there. Get us back on here, and should do that forwarding command first there. Let's go back under the OSPF routing process. It's got an option here for VRF Lite. See it? Do not perform PE checks. This comes into play when your router is running OSPF and is doing VRF Lite. You need to be aware of this here. Type 1, Type 2, Type 3 LSAs will have this down bit set. It will also, you know, you don't need to worry about it. You know, I should say not also, but you don't need to worry about it if you're, you know, a standard PE router like R6 and R3. But where you want to really worry about it is when you are running VRF Lite. And this is telling you here that I may receive routes OSPF with the down bit set. Okay. Any questions on what we've gone over here? Okay. Somebody messaged, don't external routes have tags set for the P? They do. They have tags set for the AS number. When you redistribute BGP and OSPF, the tag is set to the AS number. So they do have a tag set. What we were talking about was we were referring to type 1 and of course, type 2 and 3 routes. Okay. Any other questions here on MPLS troubleshooting?
All right, everybody, real quick, I want to spend a couple minutes talking about some layer 2 VPN scenarios. We had a couple questions throughout the week. Let me open up this document here. Okay, now the majority of stuff that we looked at so far this week related to layer 3 VPNs. So in the case that we are going to be exchanging routing information with the customers. Now MPLS, like I mentioned on Monday, it's known as multi-protocol label switching because the payload that it is encapsulating is pretty much independent. There's a lot of things that you can do with MPLS VPNs. Okay, now some of the problems that service providers typically run into with layer 3 VPNs is that first off, it requires that the provider is participating in routing with the customer. So you're assuming that the customer is not going to be sending false routing information into the network or sending too much routing information into the network. So there are some ways that you can prevent that. For example, like you can say, I want to limit the number of routes that I'll accept in this VRF. But there is still a degree of trust that's going on there between the service provider and the customer that the routing information is going to be accurate, that is going there into the table. So we're not going to send thousands of routes and then withdraw them and then send them back over and over and over. Additionally, you're assuming that the customer is going to have an edge device that is IP aware. A lot of times the customers will have just Ethernet switches, for example, on their edge, and they want to span their Ethernet LAN over the wide area network. Okay, so with a layer 3 VPN, that's not going to work because you're routing IP with them instead of exchanging Ethernet packets or exchanging frame relay. Okay, additionally, the service providers typically don't want to run every possible PE to CE routing protocol there is. So, for example, a lot of providers will say either we'll run BGP with you or we'll run OSPF with you. We're not going to run RIP, we're not going to do static routing, we're not going to do EIGRP. Okay, so depending on what the customer is already running in their network, they may not want to run OSPF inside, or OSPF with the provider edge, and then run EIGRP inside their own internal network, and then have to do redistribution between them. Okay, another problem you could run into is that when customers are trying to migrate from solutions like frame relay or ATM PVCs into MPLS, they may not want to have to reconfigure their entire networks. Because if you think in the traditional overlay model VPN, if I have a site in Los Angeles and I have a site in New York and I'm connecting them with a frame relay PVC, service provider in that case is 100% transparent. The IP address I put on in New York is going to be in the same subnet as the one in LA. Then I just configure those directly, I exchange routing information directly between them. So if we have a customer that has hundreds of sites throughout their network, that's going to be a lot of new configuration and a lot of new design that would have to go into their network in order to move to a layer 3 VPN type model. Okay, so what we can do also with MPLS is take layer 2 protocols that we are receiving from the customer, send those, encapsulate those inside MPLS, and then send that information into BGP and route it through the regular MPLS network like we've seen with the layer 3 protocols. Okay, so the advantage from the customer's perspective is that they are going to look like they're directly attached to the other customer site. So customer edge 1 device and customer edge 2 device, they're going to look as if they are directly connected. They would be in the same IP subnet or they would be in the same Ethernet VLAN. Okay, additionally, we don't need to run any CE to PE routing protocols. Okay, so the customer doesn't need to worry about what the service provider supports. Service provider doesn't need to worry about what the customer supports. Okay, for certain applications, the customers may want to extend their broadcast domain as well. Okay, so you could run spanning tree across the service provider network. You could run VTP. That type of stuff can be tunneled inside of the layer 2 VPNs. Now, for our purposes, the only one that we're going to look at on the command line real quick is a feature known as layer 2 tunneling protocol, L2TPv3. Technically, this is not an MPLS-related technology because it's used to tunnel layer 2 protocols directly over an IP network. It doesn't require that the core of the network be MPLS-related. Okay, so we can take, on our network edge, if our customer has an Ethernet link, we can configure an L2TP tunnel between our provider edge routers, and then from the customer's perspective, they're going to be in the same subnet on customer edge 1 and customer edge 2. Okay, the reason that we put a very minor focus on these technologies in the class and in the workbook is the configuration is very straightforward for these. Basically, you could look at the documentation, go through the step-by-step configuration task list, and that would be all you need to do in order to configure it. These technologies do imply that you have the core of your network built correctly first off, so you couldn't do L2TPv3 without having IP routing working end-to-end. If we look at the configuration here, first thing we're going to do is set up a pseudo-wire class. Okay, so we're setting up a class, we're saying this is the name of the class name here is L2TPv3. Okay, inside the class we're saying we're going to encapsulate traffic inside L2TPv3. The interface that I'm going to source this layer 2 tunnel off of is going to be my loopback. Okay, so on router 3 here we see on the Ethernet we're connecting to the customer edge. We're saying I'm going to start a layer 2 tunnel over to router 6's loopback address. I'm going to use the pseudo-wire class L2TP version 3. Okay, the virtual circuit ID is 1. That's just a locally significant number there. Okay, same thing on router 6. We're saying this is our class name. The protocol we're running is L2TP version 3. I'm going to source this tunnel off of my loopback. Okay, then on the customer edge, we're saying anything that comes into the customer, tunnel it over to router 3 using the encapsulation that is defined inside this class. Okay, now the previous example we were looking at earlier, we already had a layer 3 MPLS VPN built between router 3 and router 6. Okay, so let's go ahead and take a look at this on the command line. If we look at router 3, for example, and show IP route VRFB, or VRF1, I think it was, we see we have our local interface that's attached to the customer edge, and then we have the the multi-protocol BGP learned route that relates to our layer 3 VPN configuration. Okay, so if we go over to our customer here, we have layer 3 reachability over to the other customer edge, but we are exchanging routing information with the service provider network. Okay, in this case, if we look in the routing table, we can see that we're just doing static routing. Okay, but we could be running RIP or OSPF or EHRP or BGP in order to get the routing information across. Okay, now what we can do instead, let me go ahead and take this static route off. Okay, no IP route over to router 3. Okay, we'll run RIP version 2, no auto summary, on network 10. And on this Ethernet, I'm going to change my IP address. I'm going to say this is 10.1.78.7. And we are running RIP on that interface. Okay, likewise on the other customer edge, which is router 8, I'm going to go to Fast Ethernet 6 here, and our new IP address is going to be 10.178.8/24. Okay, we're going to run a RIP process, version 2, no auto summary, network 10.0.0.0. Okay, then we have a static route. Let me take this off. The static route's pointing over to router 6. Okay, so instead of exchanging layer 3 information with the service provider is just going to take our Ethernet frames, encapsulate them directly into IP packets, and then send them across between router 3 and router 6. Okay, now, technically, as they move throughout the service provider network, they will be MPLS switched because the traffic is IP traffic that is going between router 3's loopback and router 6's loopback. It's technically not an MPLS technology because we're taking the Ethernet frame, encapsulating it inside the L2TPv3 header, then that's going to be re-encapsulated inside MPLS. Okay, so first thing, we're going to create this pseudowire class. We'll say this is L2 VPN. Our encapsulation is going to be L2TP version 3. And our IP local interface is our loopback. Okay, then at the interface level, we have gigabit 01 is our customer-facing interface here. We're going to say, let me get my slides back here. Okay, so on router 3 and router 6, we're going to define these classes. We specify the encapsulation. We're saying we're sourcing it from our loopback interface. Okay, then we're saying we're making a direct layer 2 connection over to router 3, and then we're defining what our class is going to be there on the interface. Okay, so on this interface, we'll say, first off, default interface, gigabit 01. Okay, so we're taking it out of the VRF. It has no configuration on it yet. So on this interface, we'll say we're going to make a connection over to router 3 using that class. Okay, same thing on router 3. We'll get rid of the configuration that was on there before. We'll create our class here. We'll say it's L2 VPN is the name. Encapsulation is L2TP version 3. TPv3. IP local interface is our loopback. That's where we're going to source it from. Okay, so we're saying as we receive traffic from the customer, I'm going to make a connection. I'm going to send this over my layer 2 tunnel over to router 6. Now, if we look at the customer network now, show IP route RIP, we can see directly router 7 thinks that it is attached to 10.1.78.8. Okay, so if I ping 10.1.78.8, we have connectivity there. Okay, if we do a trace route, 10.178.8, we see they're directly connected. If we say show CDP neighbors, we can see on Fast Ethernet 3, it says it thinks we're directly connected to rack 8R1. Okay, so every frame, every Ethernet frame that is going out that link, it is being directly encapsulated inside of IP and forwarded over to the other edge. As you can see, the configuration on the edge is very straightforward. The only thing that we need to do is, my terminal length is 0. Okay, we define our class, we're saying as traffic comes in, we're going to encapsulate it inside L2TP version 3. Okay, the address that we're sourcing the tunnel off of is our loopback. And we're saying as traffic comes in this interface, encapsulated inside L2TP version 3, that was defined by the class, send it over to router 3. Okay, then router 3 says the same thing back. Okay, there's a question here, is there any L2TP version 3 in the core for the lab? Now, you could run into a design, let's say like you're doing carrier supporting carrier, and your tier 1 or your tier 2 ISP doesn't want to exchange IGP information with the tier 1 ISP, then you could run something like L2TP version 3 in order to configure a direct layer 2 tunnel over the link. Now, inside MPLS, there is a mechanism to do this that is called any transport over MPLS, or ATOM. It's commonly referred to as Martini tunnels as well. The original IETF draft is called Draft Martini. And basically, we're doing the same exact principle here. We're saying as traffic comes in from the customer edge, whether it's Ethernet, frame relay, ATM, PPP, etc., encapsulate that directly inside the MPLS header. Okay, so we put an MPLS tag on top of it, then send it right out to the network. Okay, based on the VPN tag that we're encapsulating on there, it's going to know what other provider edge router that it's going to. Okay, so unlike L2TP version 3, ATOM does require MPLS in the core because it's a direct encapsulation inside of MPLS. Okay, now, if you take a look at the feature navigator, you'll see that there's very few features of ATOM supported in the 12.2s trains, and it is only on the 7200 VXRs. Okay, so the versions that we're running on the 7200s, it technically supports it, but it's not enabled unless you have the VXR when it looks at it. Okay, we'll look at, in a couple minutes here, we'll look at some information about running Dynamips, and inside there you can emulate a 7200 VXR, and you can get the command set to go ahead and play around with any transport over MPLS. Okay, the majority of the support, though, is going to be on the 12.0s train, 12.0s, the service provider train, for the 7200s and the GSR. And now, if we look at the configuration, it's almost identical to the L2TP version 3. It's actually only one command on the interface. Okay, so we say we're creating a tunnel over to router 6. We're going to encapsulate it inside MPLS. Based on the routing information that we have over to router 6's loopback, that is how we are going to build the MPLS tags through the network. Okay, so we're saying as traffic comes in, put a label on it that says it's going to router 6's loopback, send it into the MPLS network. When router 6 gets it, it's going to pop the tag and see I have a regular Ethernet frame that is encapsulated inside MPLS. I'm going to forward it out the Ethernet link. Okay, so from the customer's perspective, they are in the same broadcast domain. Okay, so they will be exchanging even things like spanning tree directly over the link if they are running layer 2. Okay, ATOM also supports a feature that is called interworking that allows us to do layer 2 tunnels between different types of medias. Okay, so if the customer has an Ethernet link on one side of the network and a frame relay link on the other side of the network, we can put the same IP subnet on there, and ATOM is going to do conversion between the layer 2 protocols. So it's going to take an Ethernet frame, remove the Ethernet encapsulation, take the payload that was inside there, encapsulated inside frame relay as it goes out to the laptop on the customer edge. Again, this is only going to be in the 12.0S trains on the 7200s and the GSRs, so you're not going to see this, at least currently, within the scope of the service provider CCI lab exam. If you look at the configuration, again, it's very straightforward. We're creating a class saying that we want to encapsulate traffic inside MPLS. We define the type of interworking that we're doing. In this case, we're saying we're tunneling the traffic over an IP network. So as the traffic comes in from the customer, we see it's coming in Ethernet on this side. It's coming in HDLC or PPP or frame relay on the other side. It's 100% transparent to the customer. Okay, so an Ethernet frame comes in on router 3. It's encapsulated inside MPLS. When it gets to router 6, it takes the Ethernet frame, pulls the payload out, and then re-encapsulates it inside frame relay or PPP or HDLC, whatever protocol is running on that interface. There's also a feature known as Virtual Private LAN Service, which allows us to do multi-point layer 2 tunnels over the MPLS network. Okay, with L2TP version 3 and any transport over MPLS, those are going to be point-to-point tunnels that we need to manually provision between the provider edge routers. Okay, so the disadvantage of this, if you have 3 customer sites that are running, that are attached to the MPLS network, you're not going to be able to do layer 2 tunnels between them unless you do separate sub-interfaces to the customer. Okay, so you could have separate frame relay PVCs, or you could have separate Ethernet sub-interfaces that are attached to the customer. The Virtual Private LAN Service, it's a pretty new feature, and it's only supported as of now in the 12.0S trains of the GSR. I think the 7600 supports it, but you'll find that it's really hardware dependent. What feature this runs on, it depends on what type of WAN cards you have, like on the Flex WAN of the 6500 or the 7600. So if you look at the configuration, it's fairly similar to the other stuff, but within the scope of the service provider CCI lab exam, you don't have to worry about that. Okay, at least for now with the current platforms that they have. So, okay, there's a question here. Atom and VPLS are unlikely. VPLS they cannot test on because it's not supported on the hardware or the software. Any transport over MPLS they could technically if they wanted to, but Xlite actually says here they could test on it, but I would say that it's unlikely. Okay, the reason why, like Brian Dennis was saying earlier, the configuration is very straightforward. Okay, you only have basically 3 or 4 commands that you need to do on the provider edge in order to get this working. Additionally, when you do this, you're basically locking the provider edge router and the customer edge router into that specific configuration. Okay, where when you have a layer 3 VPN, there's a lot of other things that you can do along with it. You could do stuff like central services where you have different sites talking to other different sites. You have your different PE to CE routing protocols. So based on the number of devices that they're using, I would say that it's unlikely for you to see it. Now, you should understand what the technology is, what is the goal we're trying to accomplish. But if you look at the configuration task list in the documentation CD, you can see that it's pretty straightforward. So if they were to give it to you, I would say it would be something pretty straightforward where you're basically defining a class. They may ask you to change some options inside the pseudowire class, and then you apply it to the interface. Okay, but as compared to something like doing PE to CE routing with the customer edge and running OSPF and worrying about stuff like sham links and backdoor links, that type of stuff is a lot more complicated than doing basic layer 2 VPNs. So it's not, I mean, some of this stuff is listed in the blueprint. L2TP version 3 is. I'm not 100% sure if any transport over MPLS is, but technically they could test on whatever they want. Because like when we looked at the blueprint on Monday, they always give that, quote unquote, and other features. So other features technically could be anything in the iOS that they wanted to support. Okay, there's a question here, could you use Atom on a logical interface? Yes. So if you had like a frame with a sub-interface that was going to the customer, you could apply it onto that. Or if you had an Ethernet sub-interface that was doing trunking encapsulation, you could go ahead and apply it onto that. Okay, there's a question here. There was in the schedule we listed network convergence as one of the things that was going to be configured with internet access. We'll take a look at the documentation here real quick and see where to look at what type of that stuff. Okay, there's a question here. The Martini circuits, that is any transport over MPLS. Okay, so Atom is the term that refers to a Martini circuit. Okay, so the stuff that we covered this week, really a lot of stuff to absorb about running layer 3 MPLS over the network. Now the key, once you go beyond this class and you start going through your preparation, you start going through your, going through the workbook, going through your configuration, I want to talk about real quick the methodology that you want to think about as you're going through these technologies prior to your lab date. One of the things that Brian and I talk about typically is the different paths that you can use in order to get to the CCI lab and pass the CCI certification. Okay, a lot of people out there we see use this learning by lab approach where basically you'll go out and get a bunch of practice lab material or sit down on the command line, sit down with the documentation and just start trying to pound out configuration examples and pound out practice labs based on the questions that you're getting. The disadvantage of using this approach is that you're only learning the limited scope that is covered within that particular scenario, and you're basically memorizing how the configuration should be applied in the iOS. Okay, now you may end up passing the CCI lab using this approach. Typically, we see candidates like this are the ones who are going to the lab, 4 or 5 times before they pass. We have had students in the past who use this type of approach. We've seen candidates who've taken the lab, 7, 8, 9 times before they're passing. And basically, at that point, you're basically trying to just brute force your way through the exam by figuring out what the configuration tips and tricks are, where really there's a lot of gaps in your knowledge base. And if you basically the logic of the CCI lab is that they're trying to test your experience. Okay, the way they're trying to test your experience is giving you odd network scenarios and relying on your fundamental knowledge to reason through the questions and solve those scenarios that they're giving you. Now, when you get those type of questions, if you don't understand at a fundamental level how this stuff works, so how the multi-protocol BGP exchange works, how the layer 3 VPN works, how the label bindings and that type of stuff works, then you're going to have a real tough time in the exam trying to go through a troubleshooting process and a verification process if you just know that, well, to configure MPLS, I say MPLS IP on the interface, and then I configure a VPN address family and redistribute with the neighbor. Okay, so unless you really understand at a fundamental level first off, what are we trying to accomplish with this technology? Okay, once we know what we are trying to accomplish, we can figure out what are the different designs that they've built in there to solve different problems that the service providers are facing. Okay, based on that, you should be able to reason through the different questions they're giving you in order to figure out what configuration and troubleshooting is going to be necessary in order to solve the situation. Okay, so ultimately when you pass the lab exam, you want it to be a byproduct of the fact that you understand these technologies flat out. Okay, so when you get to the lab exam, no matter what type of question they ask you about MPLS or about multicast, that type of stuff, if you understand at a fundamental level how these technologies work, then you are going to be able to reason through the questions. Okay, now, we have a four-step approach that's listed here in order to, that I would recommend to use as you're going through your preparation process. Okay, first thing you want to do, make sure you have a basic general understanding of what the technology is, what you are trying to accomplish by using this technology. Okay, so you're going to get that by, reading through different books. If you have access to the Partner e-learning connection on Cisco's website, there's a lot of good resources on there for basic MPLS, and there's presentations where they give to customers that are a very high-level overview of stuff like MPLS and doing layer 2 VPNs. So you won't find the most technical presentations up there, but it's really good introductory material just to get a basic understanding of what is the goal that we have using these technologies. Okay, once we have that basic understanding, then you want to get onto the command line, try out some of these configurations, try to reinforce what you've already learned, do verifications, do troubleshooting, so get comfortable with the basic configurations of the technologies. Okay, once you get to that point, then you need to go back to your technical resources, so your books and RFCs and stuff like that, and make sure you really have an expert level of understanding of these technologies. One of the books that I mentioned earlier is written by a couple Juniper engineers. It's called MPLS Enabled Applications. It's a really good book, really in-depth book on MPLS, but if you're at the level where you're trying to get just a basic understanding of the technology, that's not really a good type of resource to use. So for stuff like this, as Brian Dennis mentioned, there's that MPLS Fundamentals book that's out there by Cisco Press. Then those basic presentations that Cisco has on their website as well. But once you have a basic understanding of how to do the configurations and verification, then you really want to reread a lot of this material and make sure you really understand at a fundamental level how this technology is working. Okay, once you're at that point, then you can really get into advanced configurations, and by having this reasoning process built in, you should be able to solve no matter what question is presented to you, because you know how the technology is supposed to perform, you know how to verify the stuff and how to troubleshoot it on a step-by-step basis. So even if you don't know the ultimate answer to a question just by looking at it off the bat, you will be able to use a step-by-step approach to reason through and ultimately figure out what the solution is going to be for it. Okay, now, we talked about recommended books earlier in the week. We talked about the documentation CD. Someone asked me a little bit earlier today about what version of documentation to use. I would recommend to look under 12.4 under MPLS. It has its own topic domain there. In the previous versions, it's listed under switching, I believe. But the 12.4 documentation, even though we're only using 12.2, the 12.2 S train is basically at the same level as 12.4. So it's same with the, it's kind of odd. The 12.0 S train is actually more advanced than the 12.2 S train. So the numbering doesn't always necessarily mean what type of features are going to be inside that particular version. But take a look at the 12.4 documentation for MPLS. Most of the other stuff, you shouldn't necessarily need to reference it for, like how to configure OSPF, how to configure EIGRP, that type of stuff. The BGP documentation, like I showed earlier, there is stuff like how BGP selects paths. You don't necessarily need to memorize that stuff, but you want to understand at a fundamental level how BGP works. And if you need to go to the documentation to look up syntax or look up a configuration task list, then you know that is going to be there. Okay, the technology labs that go along with the class, I would definitely recommend to go through those. It shows a lot of the typical scenarios that we did this week, and it goes through the different verifications, the stuff that you'd want to look at after you configure it to make sure that the configuration is actually functional. Okay, so once you've gone through those basic configurations, that's when we would recommend to look at to start going through the workbook labs. If you find in the workbook that there's certain parts of the technology that you don't understand, don't be hesitant to fall back to the first step of the approach, which is learning the technologies. Okay, so make sure that as you're going through this stuff that you're reading along with the books to make sure you understand at a fundamental level how this stuff is working. Okay, likewise, we mentioned this a little bit earlier in the week, but the new feature on Safari Online, the library, if you're not familiar with Safari Online, I definitely would recommend to take a look at it. You can sign up for like a 2-week trial, I think, to test it out. But especially when you're looking for specific information about a particular command, it's really great to search through the entire library of Cisco Press and figure out not only to get some information about the command, but to look at the different authors' takes on how they're explaining the technology. Okay, so typically what I find, if I'm trying to learn something like MPLS, I'll read maybe 3 or 4 different authors' versions of what they're saying about the technology, and as you look at different people's views, how they're explaining it, then it all starts to settle in. Then you could look at those more advanced resources, like looking at the RFCs or looking at the very low-level white papers. But if you start in the beginning looking at BGP, IP, MPLS, VPNs, RFC, that stuff is probably going to be way over your head. Okay, so you need to make sure that you have a foundation for the technologies. Okay, so like Brian was talking about today in the troubleshooting section, once you do your configuration, you need to make sure to verify everything. Okay, so make sure you're comfortable with the different shell commands. Things like looking at the label bindings on a hop-by-hop basis, looking at the looking at the debugs to see as the traffic is coming in, what's the label value that it's received at, what is the label value as it's going out. If you don't know how to verify this stuff, then when you do run into problems in the exam, then you're not going to have a chance. Okay, because there's a lot of twists, very small twists that they can put on these technologies that it may not be apparent when you're looking at the scenario overall, but then when you start to get into your verification process, you can realize like, oh, I'm using the wrong next hop value to reach this prefix. So it implies that I'm using the wrong label value and someone in the network is blackholing the traffic. Okay, but if you just look at it from the customer edge perspective and say, well, I can't ping, where do I start my verification? Okay, you need to make sure that as you're doing all this configuration, you're verifying it on a step-by-step basis. Okay, then if you run into problems, you should know what are the appropriate debugs and what are the appropriate show commands to go through a proper troubleshooting process. Okay, I want to spend a couple minutes here talking about equipment access for your preparation. Now, obviously you can get rack rentals from people like us. We offer rack rentals. There's some other vendors out there that are going to support our service provider topology. One of the things that's really neat, Brian mentioned it on Monday, I want to go through a quick example of it, is how to emulate the 7200 platform on your PC using a piece of software that's called Dynamips. Okay, basically what Dynamips is, it's not a router simulator per se, like you see the ones out there that they use like in the CCNA exam. It actually emulates the hardware of the router platform, and you boot actual iOS images onto the logical router instances. Okay, so it is running real iOS. So when you boot it up, it's going to have whatever syntax that version is going to have in there. It'll have all the show commands, all the debug commands. So you're emulating the hardware instead of trying to emulate the software. Okay, if we take a look at, let me open up my web browser here. There's a page on our website that I put together. And we're going to expand this here a little bit, in a little bit. That's going to show some screenshots and give you a better step-by-step process how to do it. But basically, what you need to do is go to the Dynagen website, what this is the front end that you use in order to launch the emulator. And they have a nice installer package that you can just download and it'll automatically install it. Once you get that, you need to get some iOS images. Okay, and the emulator can run 7206, 3620, 3640, and 3660. Okay, so the topology that we're using for the workbook, it's a combination of 7200s and 3600s, and there's some 3800s we're using in there as well. But once you get the emulator, there's some other requirements, like you need to install WinPCAP or libpcap, depending if you're running Linux or Windows. But once you get this, what I have set up here is these topology mappings for the workbook. There's some in here for the service provider, and there's some in here for the for routing and switching. And let me bring up what the file looks like. Okay, so basically what this file does, it's passing different options to the emulator process to tell it what iOS image that you want to run, how much memory the router instances are going to have, what type of interfaces they support. Like if we look at, it says when you boot a 7200 instance, it should have an NPE 400 with 96 megs of RAM. Okay, so depending on what your PC specs are, you may need to change this stuff around a little bit. What I have found is that if you're going to boot the entire topology, so which is going to be 9 routers plus the 3 backbone devices, and then like a terminal server and a frame relay switch and an ATM switch, you're going to need probably at least 2 gigs of RAM. And when you look in the documentation for this, you need to find an idle PC value that works with the individual image. Otherwise, you'll find that your CPU utilization goes up to 100% and it stays there. But the process is usually more memory intensive than it is processor intensive. Okay, so if you have any relatively new processor that you got within like the past 2 years or so, it should be fine. But really, you need at least 2 gigs of RAM in order to boot it. I know Brian Dennis runs it on his laptop that has 2 gigs of RAM. So you don't really need the most powerful PC. You just need a lot of memory to run it, because these instances are going to take up a lot of memory when they're booting. So you can see what it's saying. When you boot the Router 1 instance, it should be a 7200 that has a 4-port serial card, it has a 1-port ATM card, and it has a fast Ethernet interface on the I/O card. Okay, there's some initial configurations that are in here. The topology, the physical topology, is already mapped to what's going to be used in the workbook. So basically what you need to do is, once you install the Dynamis program, and let me share out my desktop here. Okay, everybody should see my desktop here. So once you install it, what you'll see there is there's a link to the actual emulator itself. This is gonna start the emulation process. Then you open up these .NET files that are going to boot the individual router instances. Okay, so if I open up the server, what you'll see is that it's starting these instances, and now it's waiting for you to boot the individual router instances. Okay, so if you just double-click on that text file that you can download for us, it's going to read through that configuration file. And what we can see here, it's going to start one of the router processes automatically. So it's starting router 1, says the RAM has got 96 megs of RAM. It's a 7206 VXR with an NPE 400 that it's emulating. Okay, so once you load this, you'll get to the console here. If you type list, you can see inside the topology, there's routers 1 through 6, there's the switches, there's the backbone devices, there's the ATM switch, the terminal server. So all of these devices are pre-set up based on that text file. Okay, so right now we can see router 1 is running. If I start up the router 3 process, okay, router 3 started, then you can telnet directly to these devices. We'll say telnet to router 1. So you can use just your console telnet if you want to do that, or you can use like secure CRT. Basically, if you just telnet to your own local address at whatever this port is that you're set up, then it'll open up the process. So let me telnet to router 1 and to router 3. And you can see router 3 is booting up as a 3640. And router 1 is already booted up. If we look at the show version output, you can see it says this is a 7200. It's running 12.225S9. Okay, so if you go to the software download page on Cisco's website, and basically they have a new feature. It's pretty neat. You can paste in the actual image name, and it'll take you right to that page to download that exact image. So if you, out of the text file, if you copy out the image name that I have in there, and then go ahead and paste it into the, if you paste it into the software download page, you can go ahead and get that specific image. So you need the image for the 7200s, and then you would need the image for the 3640. So if we look on router 3, this is a 3640 that's running 12.3T Enterprise Plus. Okay, so it's using the same topology that we were using all week long. So for example, on router 3, we could go to the serial interface. We'll say IP address 150.1.13.3. No shut. Then on router 1, serial 12, IP address is 150.1.13.1/24. And then we should have IP reachability between these two neighbors. Okay, which we do. Okay, so we could see, like, if we went to the interface, we could say MPLS IP. We'll say MPLS label protocol LDP. Label protocol LDP. Okay, so now we can see we have an LDP adjacency between the neighbors. Okay, so just like your regular show commands you would do in iOS, show MPLS LDP neighbors. Okay, we can see we're adjacent with router 3 there. If we show MPLS LDP or show MPLS forwarding table, okay, we can see we don't actually have any routes because we have just that directly connected interface. But these are real instances of iOS, so it's not a simulator per se. It's emulating the hardware and then allowing you to boot the actual image onto your PC. Okay, so if you take a look at these links, you can also, if you go to our website and then under resources, you can see basically the step-by-step instructions on how to download it and how to boot it onto your machine. It's good for doing some minor testing. You may see that if you try to boot the entire topology and you have a lot of complex configs on there, sometimes it'll be really slow. But if you're doing, for stuff like the technology labs, it's great. For the workbook labs, unless you have a really powerful PC, you may find some issues with it. You can also run it as, you can run it between different systems, like you can have 2 or 3 different PCs that the instances are talking to each other. So if you look on, they have a discussion forum that you can get the link off our website too. But if you take a look at this forum here, there's a lot of information on people running it and how they're running it between multiple machines and how to modify your configurations for your particular setup. There'll also be some information and discussion on our discussion forum if you take a look at forum.internetworkexpert.com. But if you don't already have access to equipment, then I would definitely take a look at that to supplement some of the stuff in your preparation. I wouldn't necessarily recommend doing everything on there because you could, I have seen some odd issues so far that they're not iOS related, they're related to just bad emulation. Like there's some problems with how the switching works and stuff like that. But if you keep track of the guy's website who runs the project, he fairly often releases new updates to the launcher. So you can, as he releases new versions, you basically want to upgrade that to get away from whatever bugs that people were reporting in the previous releases. Okay, before we close up here real quick, there were some questions on the network convergence stuff. And let me open up a whiteboard. Like Brian Dennis was saying earlier, when you're running LDP in your network, LDP is going to be dependent on your interior gateway routing protocol for exchanging its information. Okay, LDP and TDP, they are not routing protocols. They're taking your information that you already learned by IGP, and then they're just binding labels on top of those and advertising them to the directly connected neighbors. Okay, so when you are looking at network convergence, when you're looking at network convergence within the context of MPLS, the things that you need to think about is how can I change the convergence time of my IGP? Okay, so for things like OSPF, you can use the IP OSPF hello interval command at the interface. Okay, there's also a feature that's known as OSPF fast hellos, which allows you to do sub-second convergence. And you would say, with that, you would say IP OSPF dead interval minimal at the interface. And you could say, I want to send hellos every 500 milliseconds, or I want to send them every 250 milliseconds. Okay, you have the same type of thing with IS to IS. So at the interface level, you could say IS hello interval. You could say IS hello multiplier minimal, which is going to allow you to do fast hellos. Now, if you want to affect BGP convergence, you can do this on a per neighbor basis, or you can do it at the process level. You can say BGP timers, or you can say for this neighbor, whatever the neighbor address is, you want to affect the timers. Okay, when you do this, it is part of the negotiation inside of BGP when they're establishing their peering relationship. Okay, whoever has the lowest timer, that is going to be the value that you're going to use. Okay, so if you wanted to speed up convergence with the backbone devices, you could say set my timers, I want to send updates every 1 second and wait 3 seconds for the dead interval. Okay, once you clear the BGP process, then they would renegotiate back to those timers. Okay, then for stuff like RIP, you have your timers basic. That's going to say how often I'm sending updates. For EIGRP, that's going to be based on the IP hello time EIGRP, I believe is the syntax. But basically the same principle like OSPF and IS to IS hellos. Okay, you'll see a lot of coverage of these type of minor options in the SP workbook. You also want to make sure that you're comfortable with the commands. So spend a lot of time in the documentation CD reading through the command reference. Make sure you know what the different features are. Okay, make sure you know what the different features are inside of the individual protocols. Okay, so look at all the MPLS commands. You'll see a lot of the stuff that is not going to correspond to what we're doing. A lot of the stuff is really feature specific in the later versions. But based on going through the documentation, you'll be able to see what features are available to you and what features are not available to you. Okay, there's a question here about the recommended devices for a home lab. I'll go ahead and update. If you take a look at the SP workbook page, it lists what the hardware spec is. It's going to change a tiny bit from what's listed on there. I'm going to go ahead and update that very shortly here. But there's 7 routers and the 2 switches within the internal topology to bring it up to 9 devices. Then you have the 3 backbone devices, and then there's a frame relay switch, ATM switch, and a terminal server. Okay, so depending on how creative you want to get, a lot of these devices you can combine into one. Like your terminal server could be your frame relay switch, and it could be your backbone device at the same time if you really wanted to. But in the workbook, it'll list the specific hardware that we're using down to the modules and the specific iOS versions and stuff like that. So if you wanted to build it exactly as we have it, you could go ahead and do that. We are also going to be offering rack rentals for the SP topology here shortly. So if you just keep checking back on the website, there's going to be a lot of updates on the service provider stuff within the next week or so. We plan on getting the workbook out by Friday, and everyone in class is going to be the first to get the updates for it. Okay, so we'll make sure that we get in touch with everyone to let them know when the release date is going to be done for the workbook. Also, I do need some people to go through beta testing this week. If you do have time, whether you have access to your own equipment or not, we can get you access to some of our racks to go through configurations. If you do have your own rack, that would be helpful. But some last minute stuff we want to take a look at before we go for the final release of it. So if any of you are interested in doing beta testing this week, then just go ahead and send me an email offline, and I'll get in touch with you about the specifics on that. Okay, so the technology labs, you should already have access to the beta version on the member site. That will be automatically updated. There's going to be some more topics that we're going to add into there. And then the workbook will automatically be added to your member site accounts as well. Okay, once I get the recordings together for the class, I'll go ahead and send out an email to everyone explaining how to get access to that stuff as well. Okay, so that's pretty much going to do it for the week. Does anybody have any last-minute questions before we close up for the day? Okay, and keep in mind that you can get a hold of Brian Dennis and myself offline after class. If you take a look on the website, you can find our email addresses on there. And also there is a support forum and there's a chat server. So if you guys want to get on there and ask questions, then those are available. You can get there. The web forum is at forum.internetworkexpert.com, and the chat server uses IRC. You can get there either with there's a Java client that we have on the website, or if you have a standalone client like MIRC, then you can go ahead and connect directly to irc.internetworkexpert.com. So that's pretty much going to do it for. Okay, there's a question. Will there be a separate forum for the tech labs? It'll be just under general technologies for service provider. So if you have questions on the tech labs, then just post them on the general one that's under the SP category. So thanks everybody for attending, and good luck with your preparation for the service provider CCIE. Keep in touch with us. Let us know how your preparation is going. Feel free to post your questions on the forum. The more you guys get involved with the discussion on there, then the more it's going to help everyone out related to studying and going through the different material for this track.
Guys, I'd like to just thank you guys also for attending this week. Pretty lot to cover this week. You should have everything you need now to go to the lab and pass the lab. Don't get hung up on some of the weird stuff. Some of the stuff that's really not even supported on the platforms we're using. I mean, if you know core MPLS, you know MPLS VPNs, you know the routing protocols. I mean, you know the IP services stuff. You're going to pass. So that's what we focus on this week here. Don't get hung up on some of that weird stuff that's in the blueprint, like we talked about, that isn't really that can't even be covered in the lab there. Frame related ATM internet working and so forth there. So good luck, guys, and definitely stay in touch with us.